In 2008, plastic surgeons at Massachusetts General Hospital noticed something they couldn't explain. Children who had gotten frostbite on their cheeks healed completely, but the fat in their faces was gone. Not shrunk. Gone. The fat cells had died and never came back. This wasn't supposed to happen. Every diet book, every weight loss program, every doctor will tell you the same thing. You can shrink fat cells, but you can't get rid of them. They're with you for life. Once you make them, you're stuck with them. But these kids proved that wasn't true. Cold had done something that no diet, no exercise program, no medication could do. It had triggered a biological self-destruct sequence in their fat cells. A process called apoptosis. Those surgeons didn't just publish a paper, they started a company. It's now a billion-dollar industry called CoolSculpting. And here's what bothers me. They figured out how to charge you thousands of dollars for something your body already knows how to do, for free. By the end of this video, you'll understand exactly how cold triggers fat cell death, why this mechanism exists in every mammal on the planet, and how to activate it yourself without a single trip to a plastic surgeon's office. But first, I need to show you why everything you've been told about fat loss is incomplete. Here's what you've been told about fat cells your entire life. When you gain weight, your fat cells fill up like water balloons. When you lose weight, they shrink back down. But the cells themselves never go away. They just sit there, empty and waiting, ready to fill back up the moment you slip. This is why weight regain is so common. This is why people who lose 100 pounds often gain it all back. The fat cells are still there, sending hunger signals, demanding to be refilled. And for warm, adapted humans living in climate-controlled environments, eating whatever they want year-round, this is actually true. Their fat cells are permanent residents, but here's what the textbooks leave out. This is only true in warm conditions. In cold-adapted mammals, fat cells don't just shrink. They die. They undergo programmed cell death, a process called apoptosis, and they're eliminated from the body permanently. This isn't some fringe theory. This is how every hibernating mammal on the planet manages its fat stores. Bears don't just shrink their fat cells over winter. They eliminate them. When they emerge from their dens in spring, they have fewer fat cells than when they went in. The question is, do humans still have this ability? And the answer, based on research from NASA, from Harvard, from cold adaptation studies around the world, is yes. We absolutely do. We just never activate it. Let me show you exactly what happens at the cellular level when cold meets fat. Your fat cells have a temperature threshold. When the temperature of adipose tissue drops to around 50 to 55 degrees Fahrenheit and stays there, something remarkable begins. First, the cold triggers the release of leptin from your fat cells. Not a little bit, a massive flood. Dr. Jack Kruse describes it like this. Cold empties fat cells like a fire alarm empties a crowded theater. Everyone rushes for the exits. This leptin surge does two things. It signals your brain that you have plenty of energy reserves, which kills your appetite, and it begins the process of marking certain fat cells for destruction. Here's where it gets interesting. The cold also activates something called endothelial nitric oxide synthase. This chemical tells your hypothalamus to switch from its normal operating mode to what researchers call the ancient pathway. Your body stops expecting carbohydrates. It stops craving sugar. It shifts entirely to fat-burning mode. But the real magic is what happens to the fat cells themselves. Cold exposure triggers apoptosis, programmed cell death, specifically in white adipose tissue. The cells don't just release their contents, they commit suicide, they fragment. They're absorbed by your immune system and eliminated. This is fundamentally different from dieting. When you diet, fat cells shrink but survive. When you cold adapt, fat cells die and disappear. The number of fat cells in your body actually decreases. And here's the part that should make you angry. The medical establishment has known about this for over 15 years. They just figured out how to monetize it instead of teaching you how to do it yourself. Here's something you can test on yourself starting tonight. After your next shower, turn the water to cold for the last 60 seconds. Not lukewarm. Cold. As cold as you can tolerate. Pay attention to what happens over the next few hours. Most people notice something strange. They're not hungry. The usual evening snack cravings just aren't there. That's not willpower. That's leptin. The cold triggered a release from your fat cells, and your brain is responding by suppressing appetite. Now, 60 seconds of cold water isn't going to trigger fat cell apoptosis. That requires sustained exposure over time, but it gives you a taste of what's possible. It shows you that your body has systems you've never activated. And if 60 seconds can affect your appetite, imagine what consistent cold exposure over weeks and months can do to your actual fat cells. Now let me show you why this pathway exists in the first place. Because once you understand the evolutionary reason, everything else makes sense. 67 million years ago, an asteroid slammed into what is now the Yucatan Peninsula. The impact threw so much debris into the atmosphere that it blocked out the sun. Temperatures plummeted, photosynthesis stopped, the food chain collapsed. The mammals that survived this extinction event weren't the biggest or the strongest. They were the ones who could do something remarkable: survive extreme cold with almost no food. They developed a metabolic pathway that allowed them to burn their own fat, stores efficiently, without the crushing hunger that would normally accompany starvation. They could eliminate fat cells they no longer needed, converting that tissue into heat and energy. This pathway didn't disappear. It got passed down through millions of years of evolution, through ice ages and warming periods, all the way to you. Every mammal on Earth still has this capability. Polar bears use it. Whales use it. Hibernating ground squirrels use it. The Sherpas of the Himalayas use it, which is why NASA studied them so extensively. The only mammals who don't use it are the ones who never experience cold. The ones who live in climate-controlled environments, wear warm clothing, and eat summer foods year-round. That's us, modern humans. We have this ancient survival system hardwired into our DNA, and we never turn it on. Not all fat is created equal, and understanding the difference is crucial to understanding how cold transforms your body. White adipose tissue is what most people think of as body fat. It's the stuff that accumulates around your midsection, your thighs, your arms. Its primary job is storage. It holds energy for later use. Brown adipose tissue is completely different. It's metabolically active. Instead of storing energy, it burns it. Brown fat cells are packed with mitochondria, and their sole purpose is to generate heat. Babies are born with lots of brown fat. It's how they regulate their temperature without being able to shiver. But as we grow up in warm environments, most of us lose our brown fat. We don't need it anymore. Here's what cold exposure does. It triggers a conversion. White fat cells begin transforming into brown fat cells. This process is called browning, and it's mediated by a hormone called irisin that's released from your muscles during cold exposure. So cold doesn't just kill some fat cells, it transforms others into metabolically active tissue that burns calories as heat. This is why cold-adapted people radiate warmth even in freezing conditions. Their brown fat is working overtime, burning calories just to maintain temperature. They're not fighting the cold. They're using it. And the first fat to go? Visceral fat, the dangerous fat around your organs. Cold adaptation preferentially eliminates the fat that's most harmful to your health. Think about this for a second. Sherpas guide climbers up Mount Everest carrying heavy loads at extreme altitude. They do this in freezing conditions with minimal food, and they maintain incredible strength and endurance. NASA measured their metabolic rates and found something that shouldn't be possible. Sherpas were burning calories at 400 to 500% the rate of the climbers they were guiding. They had to eat pure butter and lard for the last 2,000 feet of the climb just to maintain their weight. Their bodies weren't fighting the cold, they were using it. Their fat cells were being converted to energy and heat at a rate that warm-adapted humans simply cannot achieve. The Sherpas aren't genetically special. They've just lived in cold conditions for 25,000 years. Their ancient pathway is fully activated. And here's what that means for you. The same capability exists in your body right now. It's just dormant, waiting for the signal to turn on. To understand why cold triggers fat cell death, you need to understand leptin. And I mean really understand it, not just the surface-level explanation you get from most sources. Leptin is usually described as the satiety hormone, the thing that tells you you're full. That's true, but it's like saying your smartphone is a calculator. Technically accurate, completely missing the point. Leptin is the master controller of your entire metabolic system. It's produced by your fat cells and it communicates directly with your hypothalamus to regulate hunger, metabolism, reproduction, immunity, and critically, whether fat cells live or die. In warm conditions, leptin works one way. It signals your brain about your energy stores, helps regulate appetite, and maintains your fat cells in a stable state. In cold conditions, everything changes. When you're cold adapted, leptin is released from fat cells in massive quantities. But here's the key. The leptin receptors in your brain become hypersensitive. They respond to much lower levels of leptin than they would in warm conditions. This means even as your leptin levels drop from fat loss, your brain still gets a strong satiety signal. You don't get hungry. Your body doesn't panic. It just calmly burns fat for fuel. And the leptin that's flooding out of your fat cells, it's not just signaling your brain, it's triggering apoptosis in the cells it came from. The fat cells are literally signaling their own destruction. This is why cold-adapted people can eat very little without hunger. This is why they lose fat without the metabolic slowdown that normally accompanies dieting. The leptin system is working the way evolution designed it to work. Let me tell you the story of how a billion-dollar industry was born from a simple observation. In 2008, researchers at Massachusetts General Hospital and Harvard were studying children who had gotten frostbite. They noticed that the fat in the affected areas didn't just heal, it disappeared permanently. They called this phenomenon cold-induced adipocyte apoptosis, fat cell death triggered by cold. They realized they could control this process, apply cold to specific areas at specific temperatures for specific durations, and you could selectively eliminate fat cells without damaging the skin or other tissues. They patented the technology. They called it Zeltic, later marketed as CoolSculpting. Today, it's performed in medical spas and plastic surgery offices around the world. A single treatment costs anywhere from $2,000 to $4,000. And what does the treatment do? It applies cold to your fat cells at around 50 to 55 degrees for about 45 minutes. That's it. That's the entire technology. Now, I'm not saying CoolSculpting doesn't work. It does. The research is solid, but here's what frustrates me. They took a natural biological process that your body already knows how to do and turned it into a premium medical procedure. Your body has been capable of cold-induced fat cell death for 67 million years. You don't need a machine. You need to understand how to activate the pathway yourself. Here's something that's going to reframe how you think about this entire topic. Fat cells aren't just storage units, they're endocrine organs. They produce inflammatory cytokines. The more fat cells you have, the more chronic inflammation you carry. This is why obesity is linked to heart disease, diabetes, cancer, and cognitive decline. It's not just the weight, it's the inflammation. When fat cells undergo apoptosis, they stop producing these inflammatory signals permanently. You're not just losing fat, you're removing sources of chronic inflammation from your body. This is fundamentally different from dieting. When you diet, your fat cells shrink but continue producing inflammatory signals. When you trigger apoptosis through cold, those cells are gone. The inflammation goes with them. Now let me show you exactly how to do this safely and effectively. Let me give you the practical framework for activating this pathway yourself. First, understand that this is a gradual process. You don't jump into ice baths on day one. That's a recipe for shock and failure and potentially dangerous. Start with your face. The face has the highest density of cold receptors on your body. Fill a bowl with cold water and ice. Submerge your face for 30 seconds at a time. Do this daily for a week. From there, progress to cold showers. Start with just the last 30 seconds of your shower being cold. Gradually increase the duration over 2 to 3 weeks until you can handle 2 to 3 minutes of cold water. The target skin temperature for activating the apoptosis pathway is 50 to 55 degrees Fahrenheit. This is cold enough to trigger the surface receptors, but not so cold that you're in danger of hypothermia. Once you're comfortable with cold showers, you can progress to cold water immersion, a bathtub with cold water and ice. Start with your lower body. Work up to full immersion over time. The adaptation period is about 2 weeks for initial changes, but the full benefits, including significant fat cell apoptosis, develop over months. Some researchers suggest 24 to 36 months for complete optimization. During this process, your diet matters. Seafood becomes important because of the omega-3 fatty acids. Your cell membranes need to become more fluid to function properly in cold, and omega-3s make that possible. And critically, avoid eating within a few hours of your cold exposure. You want your body in fat-burning mode, not digesting food. Let me tell you what happens as you adapt to cold. In the first 2 weeks, you'll notice changes in your appetite. The evening cravings that used to drive you to the refrigerator will diminish. You'll find yourself naturally eating less without feeling deprived. Your sleep will improve. Cold exposure in the evening helps regulate your circadian rhythm. People consistently report falling asleep faster and sleeping deeper. By the end of the first month, you'll notice you're radiating heat. This sounds counterintuitive, but cold-adapted people actually feel warmer in normal conditions. Your brown fat is activating, generating heat from calories that would otherwise be stored. Over the following months, body composition changes become visible. And here's what's different from dieting. The fat loss is preferential. Visceral fat goes first, the dangerous fat around your organs. Your inflammatory markers will drop. If you get blood work done, you'll likely see improvements in C-reactive protein and other inflammatory indicators. And the fat cells that die don't come back. This is the key difference. You're not just losing weight, you're changing the actual number of fat cells in your body. Now, I want to be clear about something. This isn't magic. It requires consistency. It requires patience. It requires actually getting cold on a regular basis, but the biological mechanism is real, it's well documented, and it's available to anyone willing to do the work. Here's something that might completely change how you think about metabolic disease. What if type 2 diabetes isn't a disease at all? What if it's a survival program that never got turned off? Think about what happens to mammals preparing for hibernation. They eat carbohydrates. They become insulin resistant. They pack on fat. If you tested a bear in October, it would look diabetic. But that's not a malfunction, that's preparation for winter. The insulin resistance is supposed to reverse when cold comes and the animal burns through its fat stores. Modern humans eat carbohydrates year-round. We live in heated environments. We never give our bodies the cold signal that would complete the cycle and reverse the insulin resistance. Cold exposure doesn't just kill fat cells, it restores insulin sensitivity. It completes a metabolic cycle that modern life has interrupted. I know some of you are skeptical, and honestly, you should be. Question everything, including what I'm telling you. But consider the evidence. The CoolSculpting research is peer-reviewed and published. Cold-induced adipocyte apoptosis is a documented phenomenon. No one disputes that it happens. The NASA research on Sherpas is real. Their metabolic capabilities in cold conditions are measured and documented. The evolutionary biology is sound. Cold-adapted mammals have been using this pathway for millions of years. What's new is understanding that modern humans still have access to this pathway, that we can activate it through deliberate cold exposure, that we don't need expensive medical procedures to trigger what our bodies already know how to do. The mainstream medical establishment hasn't embraced this because there's no money in it. You can't patent cold water. There's no pharmaceutical company funding research into ice baths. But the evidence is there for anyone willing to look. In the longevity of cold-adapted populations, in the metabolic profiles of cold water swimmers, in the thousands of people who've implemented these protocols and seen results that conventional medicine says are impossible. You don't have to take anyone's word for it. Your own body is the laboratory. Try it for 30 days. Track your results. The evidence will be in your own experience. I want to leave you with something to think about. We've built a civilization that eliminates cold from our lives. Central heating, warm clothing, climate-controlled everything. We've engineered winter out of existence. And in doing so, we've deactivated a survival system that evolution spent millions of years perfecting. A system that regulates our fat stores, our inflammation, our metabolic health. The obesity epidemic isn't just about food. It's about environment. We're running summer software year-round on hardware that was designed for seasonal variation. Cold exposure isn't a biohack. It isn't some fringe wellness trend. It's a return to the environmental conditions your body expects. It's giving your biology the signal it's been waiting for. Your fat cells aren't your enemy. They're doing exactly what they're supposed to do in a world of perpetual summer. Give them winter and they'll respond the way evolution designed them to respond. The pathway is there. It's always been there. You just have to turn it on. So here's what I want you to do. Tonight, end your shower with 60 seconds of cold water. Just 60 seconds. Notice how you feel afterward. Notice what happens to your appetite. If you want to go deeper, I've covered the full cold thermogenesis protocol and the ancient pathway in previous videos. Links are in the description. This isn't about suffering. It's about freedom. Freedom from the fat cells that have been accumulating for years. Freedom from the hunger that sabotages every diet. Freedom from the metabolic dysfunction that modern life creates. Your body knows how to do this. It's been waiting for the signal. Give it the cold. Subscribe if you want more content like this. And drop a comment telling me if you've tried cold exposure and what you've noticed. Your biology is more powerful than you've been told. It's time to find out what it can really do.